Something strange is happening to our planet's oceans right now. Lately, there have been increasing signs that something is wrong down there. Today I'm taking you on a journey to the wildest, most alien world on our planet, and we're diving right in. The Earth's oceans cover over 70% of the planet's surface and contain about 97% of its total water. In their depths, such as in the Mariana Trench, the pressure is so intense that it would crush us instantly. And yet life exists there that we barely understand. I regularly share updates about discoveries on our planet here on the channel. If you'd like to keep getting notifications about this in the future, go ahead and hit the subscribe button right now. Thanks a lot, everyone. Our Earth's oceans are a highly complex system full of surprises. In the Gulf of Panama, for example, something incredibly exciting usually happens every winter. Cold, nutrient-rich deep water rises to the surface, transforming this tropical region into one of the most productive habitats in the world's oceans. This phenomenon is called upwelling. In 2025, for the first time in at least 40 years, it simply didn't happen. This event has the potential to cripple entire ecosystems, but let's first understand what normally goes on there. Every January through April, the Gulf of Panama experiences a true natural spectacle. The trade winds whip across the sea and push the warm surface water away from the coast, effectively drawing in cold, nutrient-rich deep water. Nitrates, phosphates, silicates, everything phytoplankton needs to survive. And when the phytoplankton blooms, the entire food chain blooms along with it. Ultimately, the entire region benefits from this natural fertilizer from the depths. Fishing in Panama depends largely on this seasonal gold mine. During the upwelling season, fishermen sometimes catch 10 times as much as they do in other months. And then there is another, even more important effect. The cold rising water acts like a natural air conditioner for the region's coral reefs. While other tropical coral reefs suffer from rising sea temperatures and bleach, the corals in the Gulf of Panama remain relatively unharmed thanks to this natural cooling. An international research team led by Aaron O'Dea of the Smithsonian Tropical Research Institute has analyzed the data and now made a startling discovery. Normally, the upwelling current begins by January 20th at the latest and lasts for about 66 days. Water temperatures drop by an average of 19 degrees Celsius. In 2025, there was no sign of this. Temperatures didn't drop until March 4th by less than 10 degrees and only for 2 weeks. This masks an ecological disaster. The scientists have analyzed 40 years of satellite data, 30 years of buoy data, and countless water samples, and nothing like this has ever happened before. But what exactly happened? The answer is a bit frustrating. No one knows for sure. The researchers have a theory. The culprit appears to be the wind, or rather the lack of wind. The upwelling current only works when strong north winds blow the surface water away. In 2025, when the winds did blow, they were just as strong as ever, but they blew less frequently, 74% less frequently to be exact. The frequency of these important north winds was reduced by 74%. Scientists suspect a connection with the so-called This is a kind of weather highway around the equator where the trade winds of the northern and southern hemispheres meet. Normally, the so-called intertropical convergence zone migrates southward seasonally, bringing the winds with it. In 2025, this migration appears to have been disrupted. The consequences of this mysterious failure were quickly felt. Satellite images clearly showed unusually low chlorophyll concentrations, a clear sign of little plant life in the water. The situation is particularly concerning for coral reefs. Without the cooling effect of the upwelling deep water, they are exposed to much longer periods of heat. This can lead to coral bleaching, a process in which corals expel their symbiotic algae, thereby losing their color and often their lives. But is this a one-time event or the beginning of a new trend? It could be a normal climate fluctuation. After all, the ocean is a complex system with natural variations. Further research is needed to determine whether the 2025 event signals the start of future failures of this upwelling current. A particular problem is that such tropical upwelling systems are relatively difficult to monitor. While we now know a great deal about major ocean currents like the Gulf Stream, these regional systems remain relatively unexplored. Researchers are now calling for increased monitoring, better modeling, and targeted research into the interactions between oceanography, ecology, and human use. So it'll be very exciting to see what happens in 2026. But strange things don't just happen on the surface of the oceans. Our world is made up of a wide variety of elements. Your body alone is composed of numerous elements such as oxygen, hydrogen, nitrogen, chlorine, fluorine, carbon, calcium, phosphorus, sulfur, potassium, sodium, magnesium, and iron, and almost all of these elements did not originate on Earth, but have their origins in the depths of space. When very large stars eventually explode in a supernova at the end of their lives, these elements, previously created through fusion, are hurled into the vastness of space, and the immense forces of a supernova then create even heavier elements such as gold, silver, titanium, uranium, and so on. So it is not surprising, in principle, that the Earth contains elements that were created in supernovae. By specifically analyzing these elements, it is possible to determine with relative accuracy when supernovae occurred nearby during the course of Earth's history. A research team led by Austrian physicist Anton Wallner has now determined the impact that past stellar explosions had on our planet. They analyzed rock samples from the deep-sea floor of the Pacific Ocean and made a surprising discovery. The researchers were actually searching for the long-lived radioactive isotope iron-60 on the deep-sea floor. This isotope is produced in supernovae and is therefore a reliable indicator of the exact time when the effects of a supernova explosion reached Earth, and through their findings, they were indeed able to detect two explosions. One occurred about 7 million years ago and another between 4 and 1 million years ago. It is very possible that, throughout Earth's history, such explosive events from deep space may have repeatedly influenced the evolution and development of life on Earth. However, the researchers also found a few atoms of the isotope plutonium-244, and they are not entirely sure how it got there. This is because it was previously assumed that plutonium-244 is not produced in normal supernovae, but rather, for example, during the merger of two neutron stars. The results of the crustal rock analyses thus suggest that an unimaginably violent neutron star event may have once occurred in Earth's cosmic neighborhood. However, there are two other possible explanations. Either supernova explosions can become so violent that, contrary to our current understanding, plutonium-244 is indeed produced within them, or the plutonium-244 was present in the so-called interstellar medium and was blown into the solar system by supernovae. A supernova explosion could then have caused the radioactive elements from the interstellar medium to be blown into the so-called heliopause, our protective barrier against the interstellar medium, and thus reach Earth. It's incredible what the ocean floor holds, and that goes for the area deep beneath the ocean floor as well. You've surely heard of the Earth's layers, the crust, the mantle, and the core, but have you ever wondered how we even know these layers exist? That's exactly what an international team of researchers now hopes to explain in detail. They have drilled the longest hole into the Earth's mantle ever and brought a rock core to the surface. To give you an idea, the Earth's crust is just 76 kilometers thick. The mantle extends to a depth of about 2,900 kilometers, and deep within lies the Earth's core. It is our planet's powerhouse. The only problem is that this area is usually far too deep to study directly, and drilling all the way through even the thin crust is practically impossible. However, the scientists chose a very special location for their drilling, the Atlantis Massif in the mid-North Atlantic. What makes this place so special? The Atlantis Massif is located at a tectonic window. It's like a natural elevator that brings mantle rock closer to the surface. Normally, the mantle lies hidden beneath several kilometers of rock, but here, the ultra-slow spreading of the seafloor along the mid-Atlantic ridge has caused mantle rock to come much closer to the surface. The research vessel, with the evocative name Joyce Resolution, set sail in 2023 to drill at this location. Originally, the team had planned to drill to a depth of about 200 meters. Mantle rock is usually quite brittle and tends to crumble apart during drilling, blocking the drill. But for some reason, the rock behaved differently at this location. The team was able to pull intact sections up to 5 meters long out of the borehole. In the end, they reached a depth of 1.2 kilometers. In total, they recovered over 70% of the drill core as intact rock. And now, of course, the big question is what the team found in these rock cores. First and foremost, they discovered that the chemical composition of the mantle was different than expected. There is much less of the mineral pyroxene in the rocks, and the rocks have very high concentrations of magnesium, both of which are attributable to much higher amounts of melting. This discovery could change our understanding of how the mantle melts and leads to volcanism, but the truly fascinating discovery may concern the origin of life on our planet. Near the drilling site lies an area known as Lost City, a field of hydrothermal vents dotted with tower-like structures that release methane and hydrogen into the ocean. Numerous microorganisms feed on these molecules and form the basis basis for entire communities of small invertebrates such as snails and tube worms. According to some theories, life on Earth may have originated in precisely such places. When seawater seeps into the mantle, the higher temperatures heat it, creating chemical compounds such as methane, which then bubble back up through hydrothermal vents and provide fuel for microbial life. If we understand how life functions in these extreme environments on Earth, it may also help us understand how life could exist on other planets or moons. So here we are simultaneously researching our own origins as well as the potential origins of alien life forms on distant planets. Let anyone say science isn't exciting. With every drill hole like this one, with every rock core that is recovered, we get closer to answering fundamental questions. How did our planet form? How did life originate? And perhaps most importantly, are there other places in the universe where similar processes could have given rise to life? Researchers will continue to work on the samples in the coming months and years and hopefully discover even more about this fascinating place deep at the bottom of the ocean. And there is even more we don't know about at the boundary between the Earth's core and mantle. The next story begins in Antarctica. A team of researchers from the University of Alabama used a novel analytical method near the South Pole to record seismic waves that had traveled through the Earth's interior from earthquakes on the other side of the planet and were eventually detected by monitoring stations in Antarctica. The researchers were quite astonished when they analyzed the results. Right in this mysterious intermediate zone deep inside the Earth, the researchers suddenly discovered very strange anomalies. Their theory, this is likely subducted ocean floor that has gradually covered the entire region between the core and the mantle. Where tectonic plates meet beneath the ocean, huge deep-sea trenches form, such as the Mariana Trench. When these plates collide, it is called subduction, and over long periods of Earth's history, one plate slides beneath the other. In the Mariana Trench, for example, gigantic amounts of water are dragged into the Earth's interior in this way, which then pass through a still relatively unknown underground cycle and are spewed out again from deep-sea volcanoes at another location in the ocean. This entire process may also have played an essential role in the origin of life, as it is believed that the first organisms emerged in precisely such deep-sea volcanoes. However, scientists always need a very grandiose and complicated name for things, which is why they call this anomaly ULVZ. This stands for ultra-low velocity zone, meaning areas of the core mantle boundary where seismic waves suddenly travel only extremely slowly. The new research findings indicate that the entire core mantle boundary is covered by an ultra-low velocity zone due to the subsided seafloor. Its thickness varies between 1 and 10 kilometers. These anomalies thus sit atop the Earth's core like mountain ranges. These new findings help us understand the overall geophysical system of our planet. This intermediate layer within the Earth's interior could play an important role in how heat escapes from the core. And after all, this is the part of the planet that drives the magnetic field, which in turn protects us from the sun's particle radiation. This naturally raises the question of how we could find out even more about it. Seismic data, of course, are always only indirect observations, and simply digging there would be very difficult. But what if we simply stood next to a volcano and waited for material from the ultra-low velocity zones to be spewed out? No joke, material from ancient ocean floors can be carried along in mantle plumes or hotspots, which then return to the surface through volcanic eruptions. Sometimes science is just that simple. By analyzing material from specific volcanic eruptions, we could actually gain insights into this mysterious world beneath our feet. And now for a discovery that literally shakes the very foundation of our understanding of life. Marine scientist Andrew Sweetman of the Scottish Association for Marine Science and his team conducted experiments on the ocean floor. Their original intention was simply to measure how much oxygen the organisms down there consume. This is usually done using special chambers that are placed on the seafloor and then measure oxygen levels over several days. In all previous measurements of this kind, the oxygen level always dropped. Logical, since the organisms down there continuously consume oxygen, but this time everything was different. Instead of dropping, the oxygen levels in the chambers rose steadily. The first thought was the sensors must be broken. The scientists repeated the experiments multiple times in different areas of the Clarion-Clipperton zone. Time and again, the same phenomenon occurred. Oxygen oxygen is being produced down there in the depths, in a region where it should actually be impossible. After all, oxygen is produced through photosynthesis, that is by plants, algae, and cyanobacteria that use sunlight to convert CO2 into oxygen. But at a depth of 4,000 meters, there are neither plants nor sunlight. That is why the researchers call this newly discovered oxygen dark oxygen. This is truly a revolutionary discovery, because if oxygen production can occur even without the influence of sunlight, then life on Earth may have originated quite differently than previously thought. And even more exciting, if oxygen can form here on Earth in the darkness, then perhaps it can also form on other celestial bodies in our solar system, such as Jupiter's moon Europa or Saturn's moon Enceladus. But how is dark oxygen produced? A few microorganisms would be capable of doing so, but when the researchers poisoned their samples with mercury chloride to kill all the bacteria, oxygen continued to form anyway. Then they tested whether radioactive radiation from the rock might be splitting water molecules, but no luck there either. Then came the realization there were vast quantities of manganese nodules down there. These metal lumps could function like natural batteries. The nodules grow layer by layer over millions of years, during which various metals are deposited: manganese, nickel, copper, cobalt. These different metal layers have different electrical potentials, and if you measure the voltage between 2 points on such a nodule, you actually get up to 0.95 volts. Theoretically, 1.23 volts are needed to split seawater into hydrogen and oxygen via electrolysis, and with the right catalysts, it might even work with less voltage. So the nodules could actually function like millions of tiny electrolysis cells that constantly produce small amounts of oxygen. So we're talking here about a new ecosystem function that we need to take into account. 80% of the oceans remain unexplored, and now we're discovering that fundamental processes may be taking place down there that we had no idea about. Of course, there is also criticism of the study. Some scientists, interestingly from mining companies that might have other interests in the manganese nodules, doubt the results. That's why Sweetman launched another expedition from San Diego in 2026, this time with even better equipment to also search for hydrogen, the other product of electrolysis. If they find both oxygen and hydrogen, that would likely be the definitive proof of the geobattery theory, and plenty of other secrets still await us in the world's oceans. If you don't want to miss anything in the future, be sure to subscribe to the channel now, then you'll always get a notification. And that brings us to the next exciting topic. Beneath Europe, a sunken continent is currently breaking through the surface. Greater Adria is the name of this geological phantom that disappeared into the Earth's interior millions of years ago and is now slowly coming back to light. You can find the full story in the top right corner. Click on it, it's very, very exciting. In the bottom right corner, you'll find another video about science and space. Otherwise, I'd say see you in the next video. Take care, everyone.